Hey, so quick metric review and stuff. If you don't know all of these prefixes, just running through those real quick. That's capital M is for mega. That literally means a million. So if you have a megawatt of energy, that is a million watts of energy, or a mega dollar would be $1 million, right? Then you have kilo, as in kilometer, as in kilogram, as in kilomole, or whatever. Kilomole sounds kind of awesome, right? Moles are a unit we use in chemistry, right? So that is 1,000. So when they say I run a 5K, they're really meaning a 5 kilometers, so 5,000 meters, right? So you can literally replace these prefixes with that words. Then you have some less used ones, hecta, which is 100, deca, which is 10. Then you have your base unit. Your base unit has to be there. A prefix doesn't necessarily have to be there, and a common cause of confusion is the fact that meters is M. So this lowercase m will often get confused with this lowercase m, right? Because this one stands for milli and this one stands for meter. So realize there has to be a base unit of some sort. There doesn't necessarily have to be a prefix. So if all you see is a lowercase m, that's meter, not milli, right? Then you have deci, that's like a tenth. So a decadollar would be a dime, right? A decimeter would be a tenth of a meter. A cent is 100th, so it's centadollar, cent, right? That's a penny. A centimeter is like the little, the centimeters, little things we measure with, usually in science. Milli, that's about the thickness of a dime. That's 1,000th of a meter, like thousandth, not 1,000th of a meter. Then you have some unnamed ones, kind of like these here. They actually have names. Nobody uses them, so we just leave them as blanks. And then micro, when you're looking up sizes of things, you might see something listed in microns. That's like a common name for micrometers, right? Is a micron. Then you have a couple of the more unnamed ones, and then nano, and then a couple more in pico. If you don't have this handy, people tend to, after they use it a while, just remember the big ones on the three. So mega is 10 to the 6th, kilo is 10 to the 3rd, base unit is just 10 to the 0, it's just base. Milli is 10 to the -3rd, micro is 10 to the -6. So like in environmental science, I think you use some microliter things and stuff for like DNA things, or maybe in just biology. I don't know. I'm not a life science guy, right? But this is small, but not like so small you can't measure it, right? And then there's nano. That's like Tony Stark and the nanotech. We do have nanotech. It doesn't allow you to murder aliens and stuff, like little robots all over your bodies. Right? That's not what nanotech is, but we'll let Tony Stark play. And then there's pico. We do not have pico technology, so if you're having trouble remembering like which is bigger and stuff, milli, micro, nano, pico, and we have nanotechnology. We don't have pico technology, right? So maybe that helps a little bit. There's a lot of different ways you can change from one of these to the other, but oftentimes we need to for whatever reason, maybe to get things to cancel out in a problem, or like in the little mask thing we're doing, you might look up a size of oxygen, which will probably be in like nanometers or picometers, and you might look up something else that might be in microns or micrometers or something, right? So we need to be able to change between those. So if I'll just do a couple examples here. So if I have 3.7 kilomoles, right? I'll use moles, so it's one we're not as familiar with. We're going to use moles a lot in chemistry. And I want to change that to something else. I pick any other thing. So let's change that to megamoles. That sounds like the guy from that Megamind, right? Megamoles. So if you want to change kilomoles to megamoles, I go from bottom right to bottom right. 1, 2, 3. So I'm going to do the same thing with this decimal point. I go in the same direction. So 1, 2, 3. So 3.7 kilomoles is the same as 0.0037 megamoles. Again, we're just changing how it looks, kind of like when we're doing scientific notation stuff. If I wanted to do that same thing, but change it to, let's say, millimoles, look at all these M's here, right? So capital M, lowercase m. Well, scientists are very lazy, so we try and convey as much information with as little space as possible, right? So if I want to change it to millimoles, again, I'm here at kilo. Let's do that with a different color. Kilo makes scientists sound very cool. Kilomole. Right, so 1, 2, 3, 4, 5, 6. So I'm going to do the same thing here. I'm going to go 3.7, 1, 2, 3, 4, 5, 6. So that is 5 zeros, millimole. Really, we should probably just put that in scientific notation. So since it was already between 1 and 10, I could just do 3.7 times 10 to the -6th millimoles, right? And those are the same thing. If something's already in scientific notation and I want to change its power of 10, I just change the power of 10 there. So let's pause this for a second. All right, so let's say we've got 3.25 times 10 to the third micrograms, and I want that in nanograms for whatever reason, right? So it's already in scientific notation. So instead of moving the decimal point, I'm just going to move the power of 10 right here. So if I'm in micrograms and I want to go to nanograms, well, that is 1, 2, 3 powers of 10, and I'm making my units smaller, 3 powers of 10 smaller that I've done here. So I need to make this 3 powers of 10 bigger. So it's just going to be 3.25 times 10 to the 6th. And that is smushed in there where you can barely read it. So anyway, I got a little long there, but hopefully that helps with metric stuff.